Welcome everyone. Today I want to talk about developing CICD best practices with GitLab, and we do that in a little workshop today. In the next 20 minutes, I'm going to provide you with a short introduction, an overview of the first steps. We're getting started with a hands-on CICD project, which means we are using a demo Go project to test, build, and run it, and look after CICD, what's next after the workshop. To give you a little introduction about myself, I'm Michael. I'm a developer evangelist at GitLab, and I do love things open source. So before joining GitLab in March, I've been working in the open source monitoring project area. And when I'm not affiliated with anything open source, I love building Lego models. So the Lego Hogwarts model will be my next passion. If you want to reach out on social media and anywhere else, I go with DNS Miki, which is the lovely version of Michael in German. And if you want to learn more about technical evangelism, please be sure to check out the GitLab handbook. But it's not about me, it's about CICD. So let's get started. Why would I want to use CICD? Continuous integration, continuous deployment, delivery, depending on the situation. So when you keep working on a specific new feature, you want to collaborate with your colleagues, your teammates, but you don't want to disturb them with your changes because they might be breaking. You want to try things out and iterate on specific features, algorithms, and just keep working in your own space. So that's the reason why you create a new Git branch and you just keep pushing your changes. And that after some point, you might want to have a review and everything gets merged back to master, reaches to production after taking a new release. And often the release is just broken because you kind of tested it on your local machine, everything worked fine, but the production uses a different Linux distribution or something else. And basically you need to work over hours or after hours, fix the release, then fix the next release, and everything else is just not so amusing about development. And you want to make your life pretty much more easier, more relaxed, and also you want to ensure that everything runs fine. And this is the point where you might have, for example, written some unit tests or some end-to-end tests for your application already, but everyone needs to run them manually. And within GitLab CI/CD, you can automate these steps. You can define jobs in your pipeline, which automatically run the tests you created before, or you might need to add them. You can also deploy your code or your website to a review application, which then highlights exactly the state you have just committed and changed for someone to review. And you can also test specific things. One thing which is also worth mentioning is that you can also integrate security checks in CI/CD, meaning to say application security testing, dependency scanning, so that nothing gets deployed to production which might contain a security vulnerability. And that's basically the entire workflow. And it's overwhelming, I know, but we need to kind of find a way to start simple. And this is something which we are going to do now. I've prepared a project over at my GitLab namespace, so you can just check this project out. You can fork it and try it out once we go along, or maybe you watch the video afterwards, and you can just learn how to use GitLab CI/CD. So the thing is, when I navigate into the project, we will be seeing a little Golang project with the main.go and some library code. And when I, for example, inspect the main.go, I can see, okay, we're defining a main package and we're calling the main function, which kind of prints code, and getting like greeted. Hopefully it calls a function, but we just don't know what's going to happen, and basically it does something, but we're not really sure what it does. We just received the code from an external vendor, and we got the exercise to add our own features, to test it, to build it, and to ensure that everything is running smooth. So the first thing when receiving code from someone else, or when I even want to start a project, is I'm going to think about my build architecture, my build structure, and how to add automated testing and automated deployment afterwards. So the first thing I want to do now is I want to like say to my colleagues, hey, I've received this code now, I'm working on the project, and I'm going to add a new task for myself. In order to do that, I'm navigating into the issues and create a new milestone now. So I want to create a new milestone. Say, okay, this is the version 1.0, and the due date is our workshop session. And I could say in the description, this is my CICD configuration milestone. Let's just create a milestone. And the next point is, or next step is to create a new issue, which says, okay, we want to add CICD configuration for our project. And we also want to use one of GitLab's hidden powers with task lists. So I want to add the configuration, of course. I want to verify the tests are being run, and someone needs to write some docs so my colleagues know what's going to happen. In order to show you, we can have the checkboxes, and once we are going to create this issue, we're assigning to the milestone now, we can see that we can iteratively work on the specific tasks and tick them if needed. And it's also highlighted over here and also in the issue listing. So everyone knows what the state of the issue is. Now that we've said we want to create a CI/CD configuration, we actually need to do it, which is the next step. And in order to achieve that, we don't need to change into any shell or something like that. We're just staying in our repository, and we're making use of the web IDE, which is a little bit hidden over here. So this is a browser integrated interface where we can just edit the existing code, but we could also like add a new file. And we want to use this specific .gitlab-ci.yaml file, which provides or which defines the CI configuration. In this specific example, I'm not going to write some YAML code now because it's really time consuming. But we do know from the documentation that there are CI/CD configuration template files. And luckily for us, we do have one for Golang. We can just select it. If it worked, yeah, it worked. And then we get basically a predefined template. I will now just edit some parts and explain them to you later on. I just need to ensure that the repository name is the same, Collision from Home 2020. And just checking in, we want to later on work on the Tanuki binary. I'll explain the steps just in a second. I just want to ensure that the CI/CD configuration is being run in the background. For now, I'm now creating a new branch. I'm committing that and saying, okay, I'm adding the CI/CD config now. I'm just creating a new branch and call it feature CI/CD config, and also creating a new merge request. The cool thing is when I've just added these changes, created a Git branch, which would be a manual step. For now, I didn't leave the context. So I'm still within GitLab. I can create the merge request. I can say I want to use fixes and then the CI/CD configuration for a project. So when this merge request gets merged back to master, we want to auto close the issue. I can assign it to myself, might assign a milestone. Yeah, then let's just submit it and see if our source code actually compiles and what's going on. As you can see now, the pipeline is running. The pipeline is running on gitlab.com within the shared runners, so I'm sharing my resources with other users. If I do want to use my own runners, it's totally fine. So in this case, the job failed, and I can see within my pipelines, okay, it didn't continue in that regard. So the former job failed and the compiled job did nothing. I told you before I wanted to show you what specifically is going on. So we're changing back into our merge request, and I will show you within the web ID, because we can edit it. The pipeline failed, and now we're just looking what's going on inside. So the thing which happens here is it pulls the Golang Docker image, prepares something for building the Golang environment, and then it defines the stages. So first off, there's a format job which runs in the test stage. Then there's a compile job in the build stage. Whenever the test stage completes or continues, the build stage will be fired. In our case, Go vet, for example, broke. And the thing about here is when I change back to my CICD output, I can just see, okay, format has failed. It doesn't know about the specific package include. So the thing is, I kind of figured, maybe the import for the Golang code is missing. The next thing is to navigate back into our merge request. And within the merge request, there's the Open in Web IDE button where we can just fix the code. So previously we've been in our CI configuration, but we can also write Golang code inside over here, and we can fix it. So one of the fixes is to just reuse what I've commented out here, just to avoid writing too much code. And with importing that, it should fix our code. I want to commit inside the branch and fix missing package import. Let's just see if this works. Commit it. And the cool thing is, once I've committed this to the branch or to the merge request, the CI pipeline automatically starts in the background. And with the rocket icon over here, I can just check this out and see, okay, it started building. And while it builds, I can also create it in a new tab over here and just see what else is going on. Whenever format will continue, it also runs tests. And the next job stage within build will actually compile the Golang binary. So it's running some arguments for Go build, and it also defines an artifact. So the binary which is put out from Go build will be available from GitLab itself. So the runner uploads the artifacts, in this case the Tanuki binary, and hopefully the job continues, which it does. Let's just go back and check over into the pipeline, which means when the first job continued, the second one is actually compiling. And again, I need to wait a little bit because every job is just executed in its own sandbox. So that's also one of the things. You always get a reliable test environment. So every job which is being run is basically the same, and you don't have any like changes from a previous run which installed a dependency which is not there, but it's not expected to be there. This is one of the big advantages of using a container sandbox and always using the same environment. As you can see in the output, our script checks are being run, and the binary has been built, and the runner uploads the artifacts to the GitLab server. which then means, okay, I can just check out the job artifacts over here and see, oh, there's the Tanuki binary. I could download that now and just try to execute it. But it's kind of cumbersome and I don't want to do that. So I can actually verify that this is being run. And this will be achieved by adding another job to our stages, which we will be calling run. And we will like simulate a deployment now and run the script Tanuki. In order to do that, we're just navigating back over here in our CI/CD configuration, and we can see we have the deploy stages or stage already. So in this example, we're just moving at the bottom and say we want to define the run job. The names are freely definable. We're adding a tab over here, adding it to the stage deploy. You can also use autocomplete. We are using the script keyword to execute something, top dash and execute the Tanuki binary. And that's basically the thing, the third job being added. And we commit our change and say add run job and actually let that run. And we can see on the left, on the right hand side, the CI pipeline has been restarted and it runs again. It doesn't cache the previous runs because right now we have committed something. So we changed the source code or the CI configuration. So it's entirely started fresh and the pipelines keep running. And while the pipeline keeps running, as we figured that we're pulling the Golang image and it kind of takes a while, we can just check out what else might be needed or what else might be useful. So when you start coding, you might not just use Golang, you might just use a different framework. And Golang has the test framework, for example, built in, but Python or Perl or like C++ have different frameworks. So make sure to check them out and to write scripts or add them to your CI configuration. Within our Golang project, this has been achieved within the tanuki_test.go. So basically the tanuki.go implements a function which provides a string. Let's call it like that. And the test function just wraps that within the test framework and checks whether the function returns specific string items. And you can just like build that for your own functions and extend that. And it's automatically built in when you run go test and get the results back then. This is a pretty cool thing. Our chirps are still running. And the next thing is for self-practice, when you open up the MR, when it completes, you might want to auto-close the issue. So we've added the fixes #1 before. You can auto-close an issue. So when everyone approves the merge request, it gets merged back to master. And the issue gets auto-closed. So you don't have to use an extra step to automatically close the issue. You can also specify that the branch gets deleted once it merged. So your repository and your GitLab project is clean as it was before. Once everything has been merged back to Gitmaster and the issues have been closed out for the milestone, create a new release, tag a new release, and also link the milestone so everything is combined. The things which happen next for your CI/CD pipelines should be using environments for deployments. We're using staging and production. You can use review apps. You can also think about deployments with HashiCorp Terraform or Red Hat Ansible, just using the GitOps workflows. You should also think about adding specific monitoring to your CI/CD pipelines. So it's not just about a job failed, but actually your application might deploy it to a Kubernetes cluster or something else. So each Git commit might influence the performance, the application performance, or the memory usage. Just keep monitoring that, and you get a pretty exciting possibility to analyze and report why the performance was degraded by a specific Git commit, which kind of changed the backend code, and then I'll go with. And last but not least, I want to remind you about security, like runtime security and also static code analysis, dependency scanning, so why you are not responsible for it, and last but not least, vulnerability management. Let's just check whether the deployment was okay. And we can see we got our fancy Tanuki and everything worked fine. So right now we would be good to go to merge the merge request, but that's just for you. And with that, thanks for listening. If you got any questions or want to learn more about it, I've linked the GitLab training. But with that, I say thanks and waiting for the questions.